Hi again. Um, on Tuesday, the last thing we did was changing this circuit, this serial connection circuit, and we boosted the resistance of this resistor, and we wanted to see what happened. So what happens is this, that if one resistor has much more resistance than the others, then that resistor will take most of the voltage of the battery. If we would measure now the voltage in this resistor or in this other one resistor, we would see that it comes something like 0.01 volt in each of those resistors. Basically nothing. Why? Because most of the voltage, almost all the voltage, is dragged, is stolen, let's say, by this bigger resistor. That's why we don't use serial connections in buildings, for example, because if we start to connect things in serial, the voltage of the things that we previously connected will drop down, and eventually they will not work. And if we connect something which has a bigger resistance than the rest of the devices that we connect in serial, then that device will take most of the voltage and the other devices will not work. So what do we do actually? What do we actually do in buildings? We use parallel connection, which we studied already, but let's do it with Tinkercad. So for that, let's take, oh, stopped the simulation. Let's take 3 resistors like the ones before. Let's put them together, more or less together. And let's just connect them in parallel. When we connect things in parallel, we connect the beginning of each device to the beginning of the rest of the devices. So the beginnings all together, the ends all together. These 3 resistors are connected in parallel. Now let's give them some power. Let's take a 9 volts battery. We could use this one, but there would be maybe too many cables, so let's take another one. It's for free here, and let's connect them. This is the positive side of the battery. Let's connect it to this side of the circuit. Since this is the positive side, I'm gonna draw the cable I'm gonna paint it in red, the cable I mean. And here I go with the other terminal, the negative side in black. So now these 3 resistors are connected in parallel. You can mind the difference between the 3 resistors in serial and now in parallel. And if we measure now the voltage of any of these resistors, any of these 3 resistors, this one a bit more, down here, so that the voltmeter, oops, these panels are a bit uncomfortable. Okay, here we go. So let's connect the voltmeter, positive with positive, put the right color, negative with negative, the right color, black in this case. And now we have to remember the theory. When we connect things in parallel, each of the resistors will get the full power, the full voltage of the battery. In this case, 9 volts. So we should measure 9 volts for this battery, for this resistor. And the same if we did it in this resistor or in this other resistor. All of them 9 volts. In fact, when we connect it, we see almost 9 volts. There are a few centivolts missing, but it's because the device is not perfect and the cabling, all this cabling has some losses. Anyway, don't mind this really small difference. Take this as 9. So basically, each resistor will get 9 volts and not 3 volts like the ones that we had here. Remember that here you have 9 volts because we upgraded this resistor up to 1 mega. If we change change it back to 1K, you can see that here we have 3 volts and here we have 9 volts. That's why in buildings we connect things in parallel, because by connecting things in parallel we can give full power to anything that we connect, and it doesn't depend on how many things, on how many devices we have previously connected. Of course, the battery will last less time by doing this than by doing this, because we are giving full power to each of these resistors, not only 1/3 of the power, but the things will work, the devices will work properly. So for today, please just follow more or less what I did. You can make this circuit, or you can play with a little bit with Tinkercad. I encourage you to do so. You have many things to play with here. You can, for example, use a motor. Here you have motor de corriente continua, so you can use one of these motors instead of these resistors, for example, or this motor de aficionado. I've never used it before. You can try. Let's see what happens. Motor de vibración, I don't know this one either. But if you connect them, you will see how they work. And you can also make a serial and a parallel connection with motors and see the difference in their behavior, in their functioning. You will see that the motors in a serial connection, they don't work properly. They work slowly. They only have 3 volts. But if you put them like this in parallel connection, each of the motors will get 9 volts and they will work much better. You can see the difference. So enough for this week. Please do the circuit and send it to me. I remind you, here in Compartir, and you just download it. You can keep the file in downloads and then copy it and paste it in a Papas or in my email. You can attach it to an email as you want and send it to me. Next week we will start with, now that we have refreshed about serial and parallel connections, we will refresh the formulas and we will make some calculations. These classes are especially useful for those of you who still have to make it a bit better in the first term. Those of you who have a 4, a 3, a 2 in the first term, because this is basically, well, doing things that we did in the first term, and we will see how to boost that grade. First of all, please send me all these circuits and then I will tell you. Okay, as I said, enough for today. Thank you for your attention and see you next week. Bye.